Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to go over another problem on how to solve these radioactive decay kinetics type problems. And so, in this problem, we're given an ancient bone, and we're told that it contains 1/8 of the amount of carbon 14 found in living organisms. And then they're asking us how old is the bone. First thing is we need to be given the half-life of carbon 14, and that is, give me a moment, 5,715 years. So the half-life is 5,715. Oops, little dyslexia there, dyslexia. Okay. Years. Okay, so how do you go about solving this problem? Well, first you could try to use this equation here um, and solve the problem. So we know that we have 1/8 left. So here you'll notice I have three versions of this equation. This equation is used when you are asked to solve for a certain amount, right? So after a certain amount of time, how much is left? How many grams? How many milligrams? How many moles? Things like that. This here you can use to find the fractional amount that's left, right? So here, the way I got this one is I divided both sides here by n sub naught, n naught, or n sub 0. That's the initial amount. I divide both sides and I get this equation here. So this equation would be used if you need to find the fractional amount or if you're given the fractional amount. And then this one you would use to get either the percent that's left rather than the fractional amount that's left. You could use this one here to get the percent left. And all you do is you take this equation and multiply by 100 and you get the percentage. So in this problem here, they're actually telling you that the amount of carbon 14 left in the bone, right, in the bone here, the amount left is a fractional amount, 1/8 of that is found in living organisms. So you can plug that in, and we know also what else are they giving us? So they want to know how old the bone is. So basically, how much time has passed since this animal has died? Okay, um, so that would be your T. So we know we're given this. So we could use this equation here. So this would be the proper, most useful equation to use is that one because they're giving us the fractional amount, nt over n naught. And they're telling us that that's 1/8. Okay. Then we also are given the half-life, right? So the half-life is this right here, 5,715 years. So we want to find how old the bone is. That's T. So that's T right here. So that's what we want to find. So T is what? In this case, we're talking about age of the bone, the age. How much time has passed since the animal was alive? So now all we do is we take this information, we add it to this equation. So we're going to have this here, nt over n naught is 1/8, and that's equal to 1/2 to the power of t, which is what we're looking for. So t over the half-life, and the half-life is 5,000 715 years. So now all I need to do is solve this for t. So the first thing I want to do is take the log of both sides. I'm going to take the log of 1/8, and I'm going to take the log of 1/2 raised to the power of t over 5,715 years. So now I can use the fact that if I have a log of something raised to a power, I can bring that power down to the front here. So then I have the log of 1/8 is equal to t over 5,715 years multiplied by the log of 1/2. So now I can divide both sides by the log of 1/2. So this cancels out. And so now I have the log of 1, oops, that should be 1/2, not 1/8. So now I can use my calculator here to figure out what this is. So let's do that. Or I could just keep going with the calculation, but let's do the calculation and clean this up a little bit. So let's see. So we have 1/8. The log of 1/8 divided by the log of 1/2. And we get 3. So we get the exact number 3 is equal to t over 5,715 years. And I'll talk about this 3 in a moment. Why did we get exactly 3 there? So now all I do is I multiply both sides by 5,715 years. Multiply this by 5,715 years. So this cancels out. Now I have this 3 times t. So t is finally equal to 3 times this. So if I calculate that out really quick, so 3 times 5,715 equals, and I get 17,145. So 17,145 years. So that is the age of this bone. Now, let's go back to this 3. So when I took the log of 1/8 divided by the log of 1/2, I got 3. So why did I get the exact number 3? Well, other than the fact that that's how the logs work here, when you have a log of 1/8 over a log of 1/2. But let's take a look at this number here. We were told that we have 1/8 of the sample that's left. We have a fraction of 1/8. We don't have to actually use this equation. We can just use our knowledge of half-lives to figure out how many half-lives has the bone gone through to get to a fraction of 1/8. And so all we need to think about is like, well, if we start with 1, right? Let's say we could start with 1 of anything, 1 gram, 1 mole, whatever it is. So if we start with 1, then we keep dividing 1 by 1/2, or we not dividing by 1/2, but by 2. We keep taking 1/2 of the 1 until we get to the fraction that they are telling us we have at the end of the decay. So here, for my first half-life, if I divide this by 2, I get half that's left. So after this is gone, 1, if I start with 1, I have half left after one half-life. If I go through another half-life, I divide that by 2, and I get 1/4. So that's the fraction that's left after 2 half-lives. And then finally, I'll draw my arrow this way. So then after a third half-life, divide that by 2, I get 1/8. That is the fraction that I'm told that is left. Well, how many half-lives did I have to go through to get to 1/8? 1, 2, 3. So I went through 3 half-lives. I know that the half-life is 5,715. So all I need to do is take the half-life, divide it by the number of half-lives I went through, and I get my answer. So here I would take 3, multiply it by 5,715 years, and I get the same answer here. So I didn't have to use the equation. You can if you want, but if you realize that you can get to the fraction, you figure out, well, if I have this fraction, how many times do I divide 1 by half, or divide it by 2 to get to the target fraction that they give me? Okay. It may not be that you can get to that fraction by a nice whole number of half-lives, but maybe you can. Maybe you can't, especially if the denominator is some factor of 2, right? So I hope this helps you. If this makes sense, if this was helpful in any way, if you enjoyed the video, please by all means like the video, share the video with your friends, hit that like button. Also, make sure you subscribe to my channel. Hit that notification bell, but when you do, make sure that you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.